Hello, welcome back. So we're going to jump into section 2.4 now, and we're going to go back to linear modeling and using the functional notation and our knowledge of linear functions. We're going to see, try to model some things that are going on from the real world. So in this first example, the number of models of paper shredders increased from 6 models in 1994 to 31 models in 2012. Find the average rate of change in the number of models per year. Okay, so models per year, that's the key word here for finding the rate of change. So the number of so we're talking about the change in the number of models divided by the change in years. All right, so change in model, the number of models, it would be goes from 6 to 31, or you can say 31 minus 6, and then the change in years would be 2012 minus 1994. Okay, so this turns out to be 25 over 18, which we can approximate to 1.39, and the unit should be, this is in models per year. And because this is a positive number, we can see that things are increasing at a rate of 1.39 models per year. Okay, another example. At a certain college, students pay $585 for 9 credit hours and $780 for 12 credit hours. Find the rate of change of the total cost of classes in terms of dollars per credit hour. So we have dollars per credit hour. So we're talking about the change in dollars divided by the change in number of credit hours. Okay, so change in dollars would be 780 minus 585, and the change in 780, that corresponds to 12 credit hours. 585 corresponds to 9 credit hours. So this is, I'm going to compute that, that's 195 divided by 3, or $65 per credit hour. Okay. All right, now sometimes we will need to go a little further and actually find out the equation, a linear equation that models something. So what we've done is we essentially, in these examples, we found the slope. Now we're going to find the lines as well, and the linear functions that correspond to that. So let's look at this example. Number 3, for spring 2008, students taking up to 15 credit hours pay $60 per credit hour for tuition and $4 per credit hour for a general fee, and a billing fee of $21 per semester. Let H of C be the total cost in dollars of one semester for a student taking C credit hours. Okay. Now they asked you to find the slope of the graph of H. Now what's going on here is that the H of C is a function. H is a function of C. That's what this means. And so C stands for credit hours. So the cost H is a function of the number of credit hours. So we're looking at a function where we have, so H is going to be some M times C plus B. Okay, that's what we really want to do. And in part A, they're asking for the M. So one thing to keep in mind here, notice that it might be a little advantageous to just try to figure out, do part B first, and because we can sort of see from here what it has to be. Because if we have C credit hours, for each credit hour that costs $60, but then an additional $4 dollars. So 60 plus 4, we're talking about $64 dollars for each credit hour, plus a flat fee, billing fee of $21. So it's seen that H now is going to be 64C plus 21. All right, because the 64, that's 60 plus 4. That's 64, right? Okay. And so that was going to be, another way we could, it was 60C. That was the cost from the tuition, and then 4C was the cost for the general fee, and then 21 was the flat fee. So we simplify, we get this. And then the slope we can see is 64. So the slope is 64. The units of H, well, H is the cost, so this is just, the units will just be dollars. Okay. Now, part D asks, what is the domain and range of H? Now, this might seem a little strange because, we usually define the domain as a set of all possible inputs, and the range is a set of all possible outputs of a function. And if we just strictly looked at this, well, we can certainly plug in anything we want for C. So the domain, you think it should be all real numbers, but we're talking about the context of a problem, in the context of C representing the number of credit hours. And from above, we're assuming that the student is taking up to 15 credit hours. So C is bounded by 15. Okay, and then of course C has to be greater than or equal to 0. Doesn't make any sense to talk about a negative number of credit hours. So here in this, as far as this model is concerned, we're assuming C is just between 0 and 15. So this is the domain of our cost function. And then what would be the range? Well, what is the range? Well, we have this line. Okay, we have here's 0 and here's 15, and then whatever these y coordinates are, you can see that if the x ranges from, or rather C ranges from 0 to 15, then H is going to range from this number to this number. And when H is 0, we can see, or rather, when C is 0, H is going to be 21, because that's from here, right? If C is 0, H is 21. And then if C is 15, H is going to be 64 times 15 plus 21. And this turns out to be 981. Okay. So these are so H ranges from these two numbers. So H is ranging from 21 to 981. So this is the range of H. Okay? And what's going on here is basically, if you were to plot this line in the plane, the x coordinates would range from 0 to 15, and the y coordinates would range from these two numbers. Okay? That's what we're talking about. H of 9, this is pretty straightforward. We just plug C equals 9 into here. So H of 9 is 64 times 9 plus 21. And that is 597. So that would be the cost for 9 credit hours. And then the last example, it asks you to find C when H of C is 725. So H of C, remember, is 64C plus 21, and we're setting that equal to 725. We want to find the equation. We can subtract 21 from both sides, and we get 64C equals 704, and we can divide both sides by 64, And so we get C is equal to 11. All right. So that is how we do these first few examples. We'll do the rest of the examples in the next video.